So it actually, we can define a region of convergence for the power series. The greatest circle centered at G naught, such that series 1 converges. Yeah, we can make we can consider a circle, yeah, which is defined by radius, which is computed by this, actually the distance from between 2 points G naught and G something. Then we can define the greatest value of this construction. In this way, the greatest circle centered at G naught, such that series 1 converges at each point inside, is called the circle of convergence of series 1. Okay. So here greatest means by construction or definition, the series cannot converge at any point here G sub 2 outside that circle. Yeah. If we assume this is the greatest circle, then at any point outside this circle, for example G2 here, this series cannot converge from according to the theorem. Okay. Okay, let's going to check next theorem. Before that, we need to some terminology. So here, you look at some. Suppose that the power series 1 has a circle of convergence. Absolute value of G negative G naught is equal to large R. And let Sg and S sub Ng of G represent the sum of partial sums respectively of that series. Okay, here look at S of G is defined by summation from n is equal to 0 to the infinity an times G negative G naught to the n. Sn S sub n of G is defined by this formula. Summation n is equal to 0 to n negative 1 an times G negative G naught to the n, where absolute value of G negative G naught is less than large R. Then we can write the remainder function. Yeah, we already defined remainder in section 56. Log n of G is difference of S of G and Sn of G here. Since the power series converges for any fixed value of G when absolute value of G negative G naught is less than large R, we know that remainder log n of G approaches 0 for any such G as n goes to infinity. Okay? Just by definition, we can see this easily. Yeah, power series converges means that this term converges something, okay? Then the difference between these two terms, I mean S of G and Sn of G, which is log n of G, approaches 0 for any such g as n goes to infinity. According to the definition 2 of the limit of sequence, this means that corresponding to each positive number epsilon, there is a positive integer n epsilon, such that here what is log sub n of g approaches 0. The absolute value of log sub large n of g is less than epsilon whenever large n is greater than n sub epsilon. When the choice of n sub epsilon depends only on the value of epsilon, and it is independent of the point g taken in a specified region within the circle of convergence, the convergence is said to be uniform in that region. Here is another term, uniform terminology appears. Okay, next we checked theorem 2. If G1 is a point inside the circle of convergence, absolute value of G negative G0 is large R of a power series given by this formula 4. Then that series must be uniformly convergent in the closed disk. Absolute value of G negative G0 is less than or equal to R1, where R1 is equal to absolute value of G1 negative G0. Okay, you can see the figures here. Here is G0, which is the center of a circle of convergence. R1 is the distance between the point G0 and G1, and G here is variable for this power series. And there's R, which is the radius of this circle, which is defined by absolute value of G negative G0. Maybe some G should be replaced here. Then this circle means the circle of convergence. Okay.